Hello future tech leaders, I am Sindhuja. Based on my own experience, I know that learning the right skills can shape our future. What if I say learning was as thrilled as the tech world itself? There we go. A cloud foundation, that's exactly what you will experience. From day one, you will be immersed in the interactive sessions and expert-led courses that covers most of the widely used technologies in the zone of data science to cloud computing, which brings more light to the life of a techie. I'm so excited to help you and unlock the true potential of a technology. Well, then why to wait? Let's see what it unfolds.
Let's see the job scheduler that we've seen, and I think was scheduled for every 2 minutes, isn't it? For every 2 minutes, the activity is executed, and you would be able to see or trace that on the admin studio. Yes, multiple times a day for every 2 minutes. We have defined this activity to be executed. The advantage of job schedulers. You don't need to invoke it from anywhere. It's like your main method. You don't need any external invocation for it. According to the schedule you have given, the system will look after scheduling or invoking the activity as per the schedule. For example, here if you observe, the one that is selected is background processing, but I can also run my scheduler on other nodes, just like multiple threads. Understand the node as different threads. If you have a large volume of data to be processed, it is better I distribute the load onto different nodes. Now, for example, I have two other nodes here. Now, this is associated with three different nodes. Now, when my job scheduler is run, it will be running on all these three nodes parallelly. If you choose this option called all associated nodes. Otherwise, if you just choose one, this will be a single thread, which means either of these three, the system will be deciding it on runtime, and either of these three nodes will be running this schedule, which is a single thread, but if you do it on all associated nodes, it becomes a multi-thread process. Just that it speeds up the process because you are running multiple things in parallel. It will speed up the process a bit, and it will also distribute the load evenly across the different nodes. A completely part of the node management aspect. And again, all of this is taken care by the system in the runtime directly. I will not say that first 3 records should be processed in the background processing node. Next 10 records on the real-time node. I will not be able to decide that. We have one more rule type which looks after the background processing. It's called the QProcessor. I think QProcessor, by the name itself, we can understand where it queues certain things and they would be processed. Those certain things could be records. I mean, they could be data instances, they could be email instances or whatever, but the items are queued and they are processed one by one. Let's see, let us create a QProcessor. Even for this QProcessor also, I don't have any applies to class. It is applied for the rule set and the activity is where most of the logic is. That's it. This is how your queue processor looks like. But again, I have the enable disable option. The first thing that I see is, how do you want your node or queue processor to be associated with? You can choose. And here, if you observe, I can only choose one. You know, I don't have an option to choose multiple node types. I can only choose one. But earlier, when you look at the scheduler, I can have it across multiple nodes. But here I can only associate my queue processor with either one of the nodes. Multiple node is not possible on the queue processor, which is like I don't have a multi-thread process. When it's a queue, all the items will go in one single node. When do you want this to be processed? There are two different options here. There's immediate, as in whenever your queue processor is executed. Would you want the activity to be executed immediately, or would you want a delayed processing? And here number of threads per node. Within each node, how many threads are you looking at? The earlier scenario where job scheduler is there, it is applied on different nodes. It can be applied on different nodes. But here there is only one node. But within that one node, are you looking at any other threads? Are you looking at a multi-thread within a single node? If yes, we can choose this. Then we can put it to 2, 3, 4, 5. The system suggests that go with one after the other, because when you mention it is a queue. Probably a batch of 1000 records have to be processed. It's better we go in a queued order, one after the other. Then the core, your processing activity. Where is it? Somewhere on XYZ class. And this is disabled. Now my schedule is now disabled. My queue processor is enabled and with this activity. Now, when I say queue processor, there are a lot of records to be processed. There is a chance that errors might come up, or probably there could be some failures. And what should I do? Here comes your option. What is the how many times if a record fails? If of all the records, one record fails, the execution. Should I retreat or not? If yes, how many times? Your maximum attempts for retrieving is set to 3. But I can change it. I can put it to 2 or 4. How many times the system will try to process the same record if it fails? Then by how much time should it wait before retrying it? Initial delay is 1 minute. Probably the first time the system processed the record, it failed. It will wait for a minute and then it will do it again. And because you have given the attempt as 3. Yes, there's something called as delay factor, which is generally, multiplied with your initial delay. That gap is considered as the total delay time for your retrieve. If you look at this, let me click on this. This is used to calculate the time period. Are you able to see this? Calculate the period between the retrieve attempts. By how much time should I retrieve it? Initially, it takes 1 minute. After that, the retry time is 2 minutes. After that, it is 4 minutes. Likewise, depending upon the delay factor, it becomes twice. And we can have it to 3, 4. This is more like a geometric progression. How much time should I wait in between the retries? And all this is part of your error handling. What if some error comes up? How would I handle it? How many times am I retrying it? And at what intervals am I trying it? This is all part of your error handling. And just like a scheduler, I have an alert. If my queue processor is running for more than a certain time, then I would like to raise an alert, and this goes in your alert log. Let's see this. But I have two options here. One is immediate, one is delayed. Let me put it to immediate first. Like the job scheduler, this queue processor will not run by itself. Instead, I should invoke it. How can I invoke it? Either through the case type you can do it, or you can also know. In the activity, you have a method. You have a method called queue for processing. This is where you can call your queue processor. This is one launch point for the queue processor. I think let me just show you this. Or you can also do it from, I will just remove it because it's like calling a queue processor inside an activity and again calling that in a queue processor. That seems confusing. Let me just remove it here. We look at it in the case type. On the case lifecycle, I'll be able to add a method. Sorry, in fact a shape, not a method. Here I have a method and have a shape. You see a shape called run in background. This method, this shape is what you will be using for invoking your run in background is what we'll use for invoking the queue processor. Here we'll configure. Either you can configure your QProcessor here where if you observe directly, it is asking you the activity name, or let me just save it. The system is saving. I'm loading. Let me just save it for a second. Probably the first thing we should check is the execution status. Because for every run you see the last run, you will see the execution status. If it is successful, which means the execution is successful. The one that we are tracing is for the next run, the upcoming run. That is there now, that is being traced. We are low. Quick log off and log in. Let's see if the changes we have done. They will affect us more. Yes, here is your own background. And like I was telling you, you can schedule it. You can invoke your activity. For example, if you see, when you give it standard, the system is directly asking you the activity. I mean, which activity would you like to run in the background? Where you decide what activity is, and then you can give in the access group. Or for example, if you see this, and one more thing here, along with the activity, you can also give a log for that specific instance. Because when you're processing the records, acquiring a log on it, it is really important. What is your logging mechanism? Are you having it on the primary page or you have having a key defined on the property or not? Each of it. For example, if you see this, you are able to see this. When it's a primary page, you are letting the system have the PZN's key to lock your instance. Whereas if you are defining it on the specific property using that key, you can lock it. And when it is none, you are not having any locking mechanism. None is mostly used when you have just one person or there's only one person to work on the particular batch processing. There are no other parallel operators working on it or no other ways in which your data is manipulated. Then you can go for none. Otherwise, the ideal one is going to be a PZINS key. The system will look after each instance uniquely and it will lock it. Then do you need any access group in order to work on this particular activity? Because maybe the person who is working on the notifications or on the batch processing, maybe the person who is queuing the entries could be an other application or could be of other alternate access group. If that is the scenario, then you can give an alternate access group here. This is the other one, which you did not give it on the activity. Sorry, on the queue process. On the queue process, we have defined this. I mean, we have defined the class and all of it. But in case if you need a specific access group for it, then you can mention it on the access group. If the type is a queue, I mean if the type is a standard type of a queue, you are directly giving in the activity. Let's see what if it is dedicated. What would you have is the queue process. Just that you are telling the system to either directly call the activity or call the activity through a queue process. Both are one and the same, but just that here we have few other additional options on the queue process directly, like relating to your error handling or alerts nodes. All of that is taken care of the queue process. For example, let us add my queue processor. I'm going to save and run this. Now we created an activity. We call that in a queue processor. We created the queue processor. We call that on the case. Invocation is important when it comes to queue processing. But for job scheduler, you don't need to invoke it. Let's see whether my queue processor is enabled. Yes, it is enabled. Probably after this, my job scheduler would run. Yes, it should have already. Let's check. But how do I know if it's executed or not? We should go back to our studio. Admin Studio again. Here is your queue processor. Here you will be able to see the queue, processor and node type. If you see, it could be either one. I mean, only one node type is possible. And you can see, is there any broken thread? Then is anything processed in the last 1 hour? What is the state? You are disabled if you are running. Let's see. It's my queue processor. Does it have any? Yes, it has been. I think it just got one run the last time. Let's see. In fact, you can open the queue processor here also. Yes, you will be able to see. You can also create it. You can in fact remove your queue processor. It can differ, which is like disabling sort of. And if you want to look at, the status. Where is it? On page 2. It is currently running. If you would like to stop it, you can. Currently, there are no broken processes. And in fact, you can trace this as well. You see, there's an option called trace. Here, if you observe, it sees it is tracing. It is still tracing. And you wanted it in trace. Generally, what do we give for? The queue processor is a book set of records. But here we just have a log message on the tracer currently. Let us just see if that is being displayed or not. You see, it says broken. Is it broken? Let us. You can in fact see. You see the option? It says remove, or you can re-queue this item onto the processor once again. Currently it is broken, but you have an option to re-queue it. Why is it broken? Because my activity does not hold any list of instances or anything. Just a log message that it is there. The queue processors would expect that you give it a bulk set of records or something of that sort. Let us just have a look at this. Here is your option called View Data Flow, where you can see how many records were processed, how much time it took for processing the record, what is the progress of it. You will be able to see those details. Once I click on it, you can see the status. The data flow in my queue processor is in progress. The average processing time, the start time, the duration. Then you can see how many records were there, how many were successful, how many failed. You can see the run details for the system. Even though it is just on one node, I have got 20 partitions created for my queue processor. This is the node that is part of your background processing. These are your run details. What is the failure? When a data flow node fails, check the events and what happened on your queue processor. You see what has happened throughout. The queue processor on the node for background processing is this. The thread started. The partitions have changed. The thread picked up the partitions. The thread was created. The status changed. All these events have occurred. I mean, you don't need to go into much detailing here, but just to understand what events have occurred during this. We can see all those details here. In fact, you can also see. Let me just show you this. we have seen like some threads were created and some partitions were created. You see, like around 20 partitions were created here. It is being displayed, isn't it? Around 20 partitions were being created. Where did we see that? On one node, 20 partitions were created. These partitions are related to your Kafka data. For example, if you look at your Megal installation folder, suppose if you look at it, you can see Tomcat and inside which there is a folder called Kafka data. If your queue processor is successful, you will be able to see folders inside this Kafka data regarding your queue processor. There would be around 20 records, 20 folders for your queue processor. You see my queue processor. There are folders corresponding to the queue processors. Around 20 records starting from the index of 0. You see, all of this is split into 20 partitions by default. And I mean, if required, we'll be able to change it to more or less on the DS, S and all. But I mean, that is a little bit out of scope. But otherwise, we can see the queue processor has divided itself into 20 different partitions. That I would be able to process the threads in a parallel way. I can have my threads running in parallel. In each of these, I can have a thread running in parallel. Overall, you can have 20 records being processed parallel. I mean, the whole agenda is you will be able to run multiple records or you will be able to process multiple records using your queue processor. Even though it says queue, we are handling it as a multi-thread only. I have like 20 threads here, which is processing my records. You can see all the details in here. As in the status, how many records were processed. And again, the whole logic lies in your activity. Your activity has to have the list of details or it could be a list of email accounts. It could have an Excel sheet as an input or anything. Just that the more records you have, the queue processor will be able to work on those records or that kind of data. And like I said, you can in fact call it through an activity also. There's a method called queue for processing. All that we have done in running background can be done in queue processor also. Here I'll be able to just like standard or dedicated. The same options you see here on the running background, the same can be handled from the activity also. Through an activity, rest all these details. How would you have a lock on it? And what is your activity name? You can invoke your queue processor through an activity or through directly from the case type. Almost all the options that we have. Yes, it would be available in both through the activity and through the case type. Here we have options to as in when it should be invoked. And in fact, you can have it as a delayed one also. Maybe you can see it here once. Should it be immediately invoked or are you looking for a delay even for invoking the queue processor? Probably it's not that clear. But here you can in fact give it a delay as well. Probably it would be taken care at a later time. Just like both are similar to or both are associated with your standard and dedicated. If you give it standard, you will just see the activity name which is directly invoked. If it is dedicated, you can call the queue processor and that would in turn call your activity. I think we are left with integrations. We look at services and connectors. We look at simulation. Simulation is kind of a simple one only. And we have key data pages and we have DB updates. I think both of them we can pick it up in one single session. Then we have reports and we have a few other miscellaneous topics like your accessibility features, mashups. Those are comparatively very simple ones. The major ones are these integrations. We turn the data pages, DB updates and then reports. And finally, do not forget to like, share and subscribe to our channel.